Hello everyone. Yeah, this is Abhishek KB. Welcome to my YouTube channel. I hope you are all studying well. Yes, last class we started this topic differentiability, and from that we completed derivative of composite function, using chain rule, right? So today I am going to be lecturing about the next type, that is the derivative of implicit function. And the another one, that is the derivative of inverse trigonometric function. So let's start this session with the subtopic derivative of implicit function. Before going to know about the derivative of implicit function, first we should know about what is implicit function, right? So see, until now we have been differentiating the given function is of the form y is equal to f of x. We have been differentiating various function is of the form y is equal to f of x, isn't it? Yes. So it is not necessary that all the given function is of the form y is equal to f of x. It is not necessary. For example, if I consider the function x minus y minus pi is equal to 0. Call this equation 1. See, I am going to consider another function, say x plus sin xy plus y is equal to 0, and call this equation 2. See, observe the equation 1. Here we can easily solve it for y. See, x minus y is equal to y. Therefore, it is of the form, this implies y is equal to f of x. Therefore, we call this type of equation is explicit of x. That is, y is a explicit of x. See, y is a explicit of x. This type of equation is called what? Explicit function. Observe the equation 2. Here it is not easy to solving for y. Yes or no? See, x plus sin xy. Here y is a function of x. So it is not easy to solving for y. Right? So here y is a function of x. The relationship between x and y of this type, second type, is called implicit function. Is it clear? See, equation 1, the type of equation 1 is called the explicit of x. The type of equation 2 is called implicit of x. See here, in the first type of equation, we can easily getting that is easily solving for y, but here it is not possible. So this is about the implicit function and explicit function. So let us move on to the derivative of implicit function. How can we solve that? See, for your annual examination, examiner like to ask these type of questions from the derivative of implicit function. The question is, find dy by dx. Find dy by dx if x minus y is equal to pi. X minus y is equal to pi. See, answer. Here, one way of solving is, see, here what we need to find dy by dx. We need to derive the given function, say y, with respect to what? X. See, derivative of y with respect to x. So differentiate refers with respect to x, because we need to find the derivative of y with respect to x. So see, when I am going to apply the derivative for this function, see, d by dx of x minus y is equal to d by dx of pi. See, according to algebra of a derivative function, derivative of x minus y, subtraction of two functions, that is the derivative of subtraction of two functions, can be written as the derivative of the first function minus the derivative of the second function. Is it clear? This is equal to d by dx. Now see, both dependent and independent variable say, see, or by using what, d by dx of x to the power of n is equal to n into x to the power of n minus 1. Here the power of x is what, 1. So for n is equal to 1, d by dx of x is equal to n is equal to what, 1 into x to the power of 1 minus 1. 1 minus 1 implies 0. X to the power of 0 is equal to what, 1. Therefore d by dx of x is what, 1 minus, observe here, the derivative of the function y with respect to another x, that is the derivative of the one derivative of this variable with respect to another variable. Derivative of one parameter with respect to another parameter, it remains same. Is it clear? Derivative of one parameter with respect to another parameter. Derivative of the parameter with respect to the same parameter. See? Is it clear? So it is equal to 1. See, it remains same. d by dx. But see, derivative of the one parameter with respect to another parameter, I told you it remains same. But this parameter is constant function. See, this is constant, right? Pi is constant. It has the value 3.14. That is 22 by 7. Derivative of the constant function is what? Yes, 0. Very good. 0. Therefore, what we need to find? dy by dx, right? So, transfer this equation to RHS. 1 is equal to dy by dx. Or we can write dy by dx is equal to 1. See, this is the solution. I hope you are getting it. Is it clear? Yes. Let us move on to the next. Yes, please note down. Yes. Yes. Let us move on to the next type of question. Let's move on to the next type of question. Find dy by dx if x plus sin y is equal to cos x. X plus sin y is equal to cos x. Here also we are going to find dy by dx, that is the derivative of the function with respect to x. So we need to differentiate what? Differentiate with respect to x. With respect to x. When I am going to apply the derivative with respect to x for the given function, d by dx of x plus d by dx of sin y is equal to d by dx of cos x. See, derivative of the parameter with respect to the same parameter 1, or using d by dx of x, derivative of x to the power of n is equal to 1, d by dx of x is 1, plus derivative of sin y. See, if we have the derivative of y with respect to x, then it remains a dy by dx, but it contains what? Sin function. I already told you in derivative of composite function using chain rule. Here sin is the one function, y is the another function. That is the composition of two functions. We should use what? Chain rule. So you should remember when we are going to solve the derivative of function, derivative of inverse trigonometric function, derivative of logarithmic, derivative of exponential, whatever. We should use the derivative of composite function using chain rule. See, that's why I told you this is the basic tool. Is it clear? So here, see, d by dx of, see, derivative of sin x is what? Cos x by the standard result. Instead of x, what we have? Y. Therefore, derivative of sin y is what? Cos y. And see, from this we completed the first chain. Completed the derivative of the first function. Still we are remaining what with what? D by dx of y, the second function. Is it clear? This is equal to d by dx of cos x. See, derivative of sin x is cos x. Derivative of cos x is minus sin x. Minus sin x. See, here also we have two functions, cos and x. When we are going to cut this chain, cos, we are remaining with d by dx of x. We know d by dx of, that is derivative of the one parameter with respect to the same parameter. D by dx of x is what? 1. So no need to write this. After practicing, we are able to write d by dx of cos x is minus sin x. That's all. No need to write d by dx of x again. It means what? 1. So minus sin x into 1, minus sin x only. I hope you are all getting. Yes. This implies 1 plus cos y into d by dx of y. Derivative of one parameter with respect to another parameter, it remains same. dy by dx. This is equal to minus sin x. This implies we need to find what? dy by dx. We need to find. It is here. So we need to manipulate this equation. D cos y into dy by dx. Transfer this one to RHS, then it becomes what? Minus sin x minus 1. But see, when two functions are multiplied, call it as a and b, we need to find this value, say b, that is dy by dx. When I am going to transfer this multiplication function to RHS, it becomes in the denominator, right? But when you are going to transfer addition of two function to RHS, then plus becomes minus, minus becomes plus. When I am going to transfer the product, numerator becomes denominator, right? So dy by dx is equal to, from this take minus common, then equation becomes sin x plus 1. Whole thing divided by what? Cos y. See, this is the answer for this question. I hope you are all getting this. Yes, please note. Yes, let us move on to the next problem. Find dy by dx for x square plus xy is equal to tan x plus y. We need to find the derivative of the function. Derivative of which function? It is a implicit function. Is it clear? Yes. Differentiate with respect to x as usual, because we need to differentiate this function with respect to what? X. That's why we need to differentiate this equation with respect to x. When I am going to apply the derivative for this, d by dx of x square plus d by dx of xy is equal to d by dx of tan x plus d by dx of y. Then see, d by dx of x square, it is of the form x to the power of n. D derivative of x to the power of n is n into x to the power of n minus 1. Instead of n, what we have? 2. When I am going to apply the derivative for x square for n is equal to 2, 2 into x to the power of 2 minus 1 is 1. Therefore, derivative of x square is 2x plus derivative of xy. See, here we have two functions. derivative of first function into second function is what? First into, see, derivative of first function into second function. When we have the two function, here we have x and y. See, answer for this is first into derivative of second plus second into derivative of first. See, if I am consider x as the first function, y as the second function, first function is x into derivative of the second plus second is what? Y. Second function is y plus into derivative of first. Derivative of first function is x. This is equal to derivative of the tan x. What is derivative of tan x? It is secant square x. By the standard result, derivative of tan x is secant square x. Here also we have no function. When I am cutting this tan, we remain with x. Since we are going to differentiate this function with respect to x, d by dx of x is 1. So no need to write d by dx of x. Plus derivative of one parameter with respect to another parameter, it remains dy by dx only. See, here also, see, d by dx of y is what? dy by dx. Here also we have dy by dx. In RHS also we have dy by dx. We need to find dy by dx. Just by taking LHS to RHS and RHS to LHS. That's all. See, here we don't have dy by dx. So transfer this expression to RHS. We are going to put x into dy by dx. Plus, see here y into d by dx of x, y into d by dx of x, it is equal to what? 1. So I can directly write this as y. See here also we don't have dy by dx. Transfer these two to RHS. See, secant square x minus 2x minus y. But here I have dy by dx. Transfer this RHS to LHS. Then plus becomes what? Minus dy by dx. From these two, what we have common? Take common as dy by dx, right? dy by dx. Here we are with what? X minus 1. Then this becomes product of dy by dx and x minus 1, right? So this is equal to secant square x minus 2x minus y. When I am going to transfer this x minus 1 to RHS, this x minus 1 becomes denominator because this is in product. We need to find dy by dx. So this is equal to secant square x minus 2x minus y whole thing divided by x minus 1. So this is the answer for this. So the examiner requires this type of question for our annual examination in part B for 2 marks. Is it clear? Please note. Yes? Let us move on to the next type of problem. Find dy by dx for x square plus xy plus y square is equal to 100. This question was in 2015. Examiner asked this question in 2015 for 2 marks. Okay. See again, same rule. Differentiate with respect to x for the given function. And I am going to apply this derivative d by dx of x square plus d by dx of xy plus d by dx of y square is equal to 100. Is equal to 100. This implies, see, derivative of x square. It is of the form x to the power of n for n is equal to 2 dividing 2x. We already solved this in previous one only. D by dx of xy. Again, first into second. D by dx of first into second. First into derivative of second, that is it remains dy by dx plus second into derivative of first. D by dx of x is what? 1. So simply write it as 1 plus d See, derivative of one parameter with respect to another parameter. See, this is not the single function y square. It is a composite function because y square. Both are different variable. So first we need to find the derivative. It is of the form what? X to the power of n. It is of the power what? X to the power of n. Y square can be written as y into y. Y into y function of composite function of same variable but 2 times. So we need to apply this one, that is derivative of x to the power of n. It is of the, instead of x what we have y, different variable. See, if I am going to consider derivative for y to the power of n into y to the power of n minus 1, that is 2 into y to the power of 2 minus 1 gives 2y into derivative of remaining with what? See, cutting this time power, we are remaining with this function, right? This is equal to d by dx of 100, right? We need to apply the derivative of this constant also. Derivative of constant is what? 0. Then this becomes 2x plus x into dy by dx. We have plus 2y into dy by dx plus y. That is transfer 2x plus y to the RHS. Then it becomes what? Minus 2x plus y. See, we need to find dy by dx. So take dy by dx as common from these two. We are going to get x plus 2y. This is equal to minus of 2x plus y. Whole thing divided by, I am going to transfer this to this side. X plus 2y. X plus, that is dy by dx is equal to dy by dx is equal to minus of 2x plus y divided by x plus 2. So this is the way to find derivative of what? Implicit function. This is what to do. Please note down. Yes, after completion of the derivative of composite function using chain rule and the derivative of implicit function, let us move on to the derivative of inverse trigonometry function. We already learned about the inverse trigonometry function in chapter 2 only, right? So let us move on to the derivative of inverse trigonometry function. We are all know there are 6 inverse trigonometric ratios: sin inverse x, cos inverse x, tan inverse x, secant inverse x, cosecant inverse x, and cot inverse x. Here we are going to find the derivative. It is represented by what? d by dx. The derivative. See, here we have the variable x. That's why derivative with respect to x. Derivative for this inverse trigonometric function. The question arises, sir, how can we derive this? How can we get the formula for derivative of sin inverse x, derivative of cos inverse x, derivative of tan inverse x, similarly secant inverse x, cosecant inverse x, and cot inverse x, right? So, see, here the given function is what? Sin inverse x. It is denoted by f of x. F of x usually denoted by y. So, simply take it as y is equal to sin inverse x. Call this equation 1. From this, y is equal to sin inverse x implies sin y is equal to x. Isn't it? See, inverse trigonometric function transferred to LHS. This RHS function transferred to LHS. Inverse trigonometric function becomes trigonometric function, right? So now differentiate with respect to x. See, differentiate this with respect to x. That means what? d by dx of sin y is equal to d by dx of x. See, where are no derivative of sin y, that is cos y. See, here we have two different functions for the given dependent variable, right? See, sin y is another function, so we need to differentiate this, that is dy by dx. We need to differentiate this by with respect to x. This is equal to derivative of x with respect to x. It is equal to 1. It is equal to what? 1. See, this implies we need what? Dy by dx. Dy by dx is equal to 1 by cos y. Therefore, see, this implies d by dx of here what we have y. Y is equal to what? Sin inverse x is equal to 1 by cos y. See, the result should be in form of x. The resultant of this derivative should be contains the variable x. Why? See, the given function is of the form sin inverse x. It has the variable x. So the result should be in x only. So how can we think that? See, cos y. See, we know that sin square y plus cos square y is equal to 1. Yes. See, cos square y is equal to what? 1 minus sin square y. But what we want? We want cos y. Therefore, cos y is equal to square root of 1 minus sin square y. Therefore, cos y is equal to square root of 1 minus. See, x is equal to sin y. What about sin square y? Or y is equal to, sorry, x is equal to sin y. What about x square? It is sin square. Therefore, sin square y can be written as x square. Therefore, the result can be getting in the form of x. See, derivative of sin inverse x is 1 divided by square root of 1 minus x square. Is it clear? Simply take y is equal to sin inverse x, the given function. Convert this inverse trigonometric function to trigonometric function. We all know the trigonometric function, derivative of trigonometric function, right? By the standard result, we already learned in class 11 and we already noted down the derivative of sin x, cos x, tan x, secant x, cot x, cosecant x. So, differentiate this with respect to x. Derivative of sin y is equal to derivative of x. Derivative of sin y is cos y with derivative of y with respect to x, because we have y with respect to the different parameter is equal to derivative of x is 1. Then dy by dx, we need what? Dy by dx, that is dy by dx of y is equal to what? Sin inverse x. Therefore dy by dx of sin inverse x, LHS getting is equal to 1 by cos y. The resultant should be in variable x only. Here we have y. So convert this by using the first identity of trigonometry. Sin square y plus cos square y is equal to 1. Cos square y is equal to 1 minus sin square y. Cos y is equal to square root of 1 minus sin square y. Cos y is equal to square root of 1 minus sin square. That's why I told you the identities for of trigonometric function and inverse trigonometric function are the very basic tool to learn differentiation and integration. Those are very basic. That's why you should remember sin square x plus cos square x is equal to 1. 1 plus tan square x is equal to secant square x. 1 plus cos square x is equal to cosecant square x. Sorry, 1 plus cosecant square x is equal to cot square x. Those are the first three identities, right? You should remember. See, therefore, derivative of sin inverse x is equal to 1 minus 1 divided by square root of 1 minus x square. Similarly, take for the next function, this is equal to 1 divided by square root of 1 minus x square. Similarly, taking y is equal to cos inverse x, cos y is equal to x, differentiate cos y is equal to the same RHS cos y. See, derivative of cos y is what? Minus sin y into dy by dx. dy by dx is equal to minus 1 divided by what? Sin. What sin? See, using the same identity, sin square x plus cos square x is equal to 1. We need what? We need sin y, right? Sin square y is equal to 1 minus cos square y. Therefore, sin of 1 minus cos square y. Sin y is equal to sin y is equal to sin square y is equal to sin y is equal to square root of 1 minus cos square y. 1 minus c. Y is equal to cos inverse x. Cos y is equal to x. Cos square y is again it is x square. Therefore it is equal to what? C minus 1 because the derivative of cos y is minus 1 divided by square root of 1 minus x square. Therefore we conclude that the derivative of cos inverse x. See, shall I write it? Yes, please note down. See, this is the way to find the derivative for inverse trigonometric function. Yes. Therefore, we are getting derivative of sin inverse x is 1 divided by square root of 1 minus x square. Derivative of cos inverse x is minus 1 divided by square root of 1 minus x square. Similarly, derivative of tan inverse x is equal to 1 divided by 1 plus x square. Derivative of cot inverse x is equal to minus 1 divided by 1 plus x square. Derivative of secant inverse x is equal to 1 divided by x into square root of x square minus 1. Derivative of cosecant inverse x is equal to minus 1 divided by x into square root of x square minus 1. I leave these four results to prove. I leave this proof to you only. Okay, you should prove by taking the function again, convert it into trigonometric function, differentiate that by using. See, here by using the first identity, we have two more identities. That is 1 plus tan square x is equal to secant square x. 1 plus cot square x is equal to cosecant square x. And the first identity is sin square x. Instead of x, we took y. That's all. Sin square y is plus cos square is equal to 1, or sin square x plus cos square x is equal to 1. I hope you are all getting this. Yes. Please note this. Yes, let us move on to the problems on the inverse trigonometric function. That is the derivative of inverse trigonometric function. We already proved the derivative of sin inverse x is equal to 1 divided by square root of 1 minus x square. Similarly for cos inverse, tan inverse, cot inverse, secant inverse, and cosecant inverse, right? So let us move on to the problems using those results and add these 6 results to our formula list. We have a formula list, right? That is based on the class 11. We already proved those results on class 11 and we wrote down. And add these 6. This is from the class 11. Okay? Yes. Find dy by dx. Consider the first one. If y is equal to sin inverse of 2x into square root of 1 minus x square. See, sin inverse of 2x into square root of 1 minus x square. We already did this problem in chapter 2. This is by what? Simplifying this function. How can we getting the result? See, first and here I am going to give one clarification. See, y is equal to sin inverse of 2x into square root of 1 minus x square. We know the derivative of sin inverse x. Derivative of sin instead of x, what we have? 2x into square root of 1 minus x square. It is not possible to apply this formula. 1 divided by square root of 1 minus. Instead of x, what we have? 2x into square root of 1 minus x square. So first we need to simplify this. Then we need to apply the derivative. Okay? How can we simplify that? See, answer. This is the given function. Given y is equal to sin inverse of 2x into 1 minus x square. See, put x is equal to cos theta. Put x is equal to cos theta. This implies theta is equal to what? Cos inverse x. When I am going to apply this x is equal to cos theta for the given function, then I will get sin inverse of 2 cos theta square root of 1 minus cos square theta. See, this implies sin inverse of 2 cos theta square root of 1 minus cos square theta is what? Sin square theta. By using sin square theta theta plus cos square theta. By theta equal to what? Sin square theta plus cos square theta is equal to 1. And I already told you, I will let us discuss it on later. Yes, 2 cos theta equals 1 minus sin square theta is cos square theta. Square root get cancelled. We are remaining with what? Sin inverse of 2 cos theta into sin theta. This is equal to sin inverse of 2 cos theta into sin theta is what? Sin 2 theta. See again. See these are all we already did in chapter 2. We are going to simplify this by converting this sin inverse of 2x into square root of 1 minus x square is of the form sin inverse x. See, sin inverse of sin 2 theta. Sin inverse sin get cancelled. We are remaining with y is equal to 2 theta. But theta is equal to what? Cos inverse x. Y is equal to cos inverse x. Therefore, sin inverse of 2x into sin root of 1 minus x square can directly written as cos inverse x. Or you can directly write this is equal to cos inverse x. You should know the result from the inverse trigonometry. There is no need to write all this. If you have any doubts regarding the results, then go through these steps. No problem. Whether you are right or not, if you are no, directly go through sin inverse of 2x into square root of 1 minus x square is what? 2 cos inverse. 2 into theta. Theta is 2 cos inverse x. If you don't know the procedure, then go through this. Substitute x is equal to cos theta. Why we are using this? See, sin square theta plus cos square theta is equal to 1. Square root of 1 minus cos square theta. 1 minus sin square theta. I already told you while solving this kind of problem, we are going to use the first three identities. Sin square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to secant square theta, and the third one is 1 plus cot square theta is equal to cosecant square theta. Yes, out of these, for this we need to use this. Either you take x is equal to cos theta or x is equal to sin theta, no problem. If they ask find dy by dx, then you may take x is equal to cos theta, x is equal to sin theta. Because the result says, we have sin square theta plus cos square theta is equal to 1. Therefore, it becomes what? Y is equal to 2 cos inverse x. This function becomes 2 cos inverse x. Now, differentiate with respect to x. Because we know the derivative of cos inverse x. If you take x is equal to sin theta, then it becomes 2 sin inverse x. Then also you have right to apply the derivative with respect to x, because we know the derivative of sin inverse x. Is it clear? Therefore, d by dx of y is equal to 2 into d by dx of cos inverse x. Therefore, d by dx of y, derivative of one parameter with respect to another parameter, it remains same. Therefore, we are getting the LHS dy by dx. dy by dx is equal to 2 into derivative of cos inverse x is minus 1 divided by 1 plus x square. Sorry, minus 1 divided by square root of 1 minus x square. By using this, see, this is the result. dy by dx is equal to minus 2 into minus 1 minus 2 divided by square root of 1 minus x. Similarly, y is equal to secant inverse of 1 minus 2x square minus 1. For which trigonometric function, for which substitution for this x, you are going to getting out of 6 inverse trigonometric function, you are going to getting one inverse trigonometric function. So for which substitution it is possible? Just think about it. See, I hope you all write down this. Yes. So this is for the solution. This is the solution for this first problem. Let us move on to the second answer for the second one. Given y is equal to secant inverse of 1 divided by 2x square minus. See, put x is is equal to cos theta. X is equal to cos theta. Then y is equal to secant inverse of 1 divided by 2 cos square theta minus 1. See, this implies theta is equal to cos inverse x. Then secant inverse of 1 divided by 2 cos square theta is cos square theta minus 1. That is cos 2 theta. Where are no? The result. Sin 2 theta is 2 sin theta into cos theta. But cos 2 theta is 2 cos square theta minus 1. Therefore, 1 by cos 2 theta is secant inverse of 1 by cos theta is secant theta. 1 by cos 2 theta is secant theta. And therefore, we have to cancel this. If you are going to consider sin square theta, then there is no result. Then it is not possible to getting this. Therefore, we should take x is equal to cos theta, 2 cos square theta minus 1, 1 by cos 2 theta, sin secant theta, secant inverse secant get cancelled, then 2 theta. Theta is equal to what? Cos inverse x. Y is equal to cos inverse x. Now we are going to find this dy by dx by applying the derivative. Differentiate with respect to x. Therefore, dy by dx is equal to 2 into d by dx of cos inverse x. Again, getting the same result. 2 into minus 1 divided by square root of 1 dx. That is 2 into minus 1 is minus 1. Therefore, d by dx of y is what? Y is secant inverse of 1 divided by 2x square minus 1. See, this is equal to this. I hope you are getting this. Similarly, for y is equal to cos inverse of 1 minus x square divided by 1 minus x square. See, within a second, you should remember cos inverse of 1 minus x square divided by 1 plus x square is cos 2 theta. By putting x is equal to tan theta, because 1 minus tan square theta divided by 1 plus tan square theta is cos 2 theta. By getting this, cos inverse cos get cancelled, remaining with 2 theta. Remaining with 2 theta. X is equal to what? Tan theta. Theta is equal to tan inverse x. That is 2 tan inverse x. By applying the derivative for this, 2 is constant, take outside. Derivative of tan inverse x is 1 divided by 1 plus x. 1 divided by 1 plus x. Therefore, the derivative for this dy by dx, we need to find this, right? Dy by dx is equal to 2 divided by 1 plus x. 1 divided by 1 plus x square. I hope you are getting this. So this is about the derivative for inverse trigonometric function. And from this, we completed 3 type of problem in derivative. That is in differentiability. In part 2, we completed the derivative of composite function. Derivative of composite function using chain rule. And the second one is derivative of implicit function. Derivative of implicit function, and we completed the derivative of inverse trigonometric function. And from this, you are getting 1 mark for your annual examination, and from this, you are getting 2 mark question, and from this also, you are going to getting 2 mark question for your annual examination. And in the first part, we did what? Continuous function at a point. And I will tell you from this, we will getting 4 mark question in part E. And from this, we completed 4 plus 1 5, 5 plus 2 7, 7 plus 2 9. We completed 9 mark for your annual examination. I told you from this chapter, you are getting 20 mark. Right? And nearly completed 50% of this chapter. And in the next class, I am going to give a lecturing about the derivative for logarithmic function, derivative for exponential function, and the derivative of parametric function. See, I will meet you in the next class. Yes, I hope you are all start getting these subtopics in chapter 5. Safe well. Take care. Bye bye.